Now, talking about spinning clouds, there's another version called hurricanes, or if you're in the Pacific and over towards, that side of the planet, they call them typhoons. Much bigger, lots more water involved. There's kind of a cross section of what hurricanes look like. In the middle of which it gets very quiet, because things are just peaceful and quiet in the eye of the storm. Now, I live here in Houston, and yes, we managed to make it through Hurricane Harvey that decided to dump 23 trillion gallons of water on us over a period of about 3 days. This is what Hurricane Harvey looked like. This is the Texas coast up towards the top left. Yeah, that was a big storm. And guess what? They've got a scale for measuring hurricanes, cyclones. It's called the Saffir-Simpson hurricane category. And since you live in Panama, George, you probably heard these terms: tropical disturbance, tropical depression, tropical storm. And then we move into category 1, 2, 3, 4, and 5. Look at the middle column. Really, it boils down to a function of what's the wind speed. So if we got less than 23 mile an hour winds, it's a disturbance. 23 to 38, it's a depression. Classified as a tropical storm if you get up above 38 miles an hour, 39 to 73. Once you cross 73 and get up to 74, up to 95, it's a Cat 1 hurricane. 96 to 110 is Cat 2. Up to 111 to 129, Cat 3. 130 to 156, Cat 4. And then you get above 156 miles an hour, it's a Cat 5. Now that can deliver a lot of rain and do a lot of damage. But what's even more interesting, look at the rightmost column, storm surge. Because of the winds, because of the change in atmospheric pressure, the ocean is affected. The ocean over which it's traveling is affected. And you get the level of the ocean coming up in feet. So south of Houston is when you get out across onto the island of Galveston. Okay, there's a section of the beach called the seawall. It's got lots of reinforced concrete and granite and things like that. And it's about, let's see, let me think about it. From the beach up to where the road is easily 20 feet or so. And every time we get a big hurricane coming in, that seawall gets hammered by the storm surge. George, you guys get storm surge down there?
We are super duper close to the coast. Like the city is very, very close to the coast. But the way Panama City is laid out, we have a natural wave breaker. Like the side of
Okay.
our country has this thing, so we never get super crazy big storms coming on this side. When they come through from the Atlantic side, Colon.
Yeah.
Every once in a bajillion years, which is nothing, we get a storm that just is big enough that goes through. Last time was in 1986. I was in 4th grade, and we had to hide under our desks. All the windows of all the buildings, the trees were like ripped. It was like I have those images tattooed in my brain. Because I was like, what, 5, 6 years old? Something? No, it was 8, 9.
Yeah.
All the trees ripped off, like twigs. Incredible. Yes, it does happen.
Yeah. Yeah. When Katrina Hurricane Katrina came through and beat the snot out of Louisiana. And when was that? 2008, I think it was. I saw pictures of forest pine forests of pine trees over in Louisiana that about 20 feet up in the air, it looks like somebody just took a like an axe and just lopped them all off, right? All at the same level. Shoo. That's, the winds came through and just like whoosh, ripped them all off, chopped them all off at the same level.
It's just
Just,
water and wind.
yeah.
It's just water and wind. That's a crazy thing. It's not like, like it's just water and wind. And one thing, Professor, do these phenomenon occur in other planets, or are they a function of the elements, or is it like if it's like I don't know, Jupiter or one of those gas planets? Do they have tornadoes? Do they have thunderstorms? Like,
Okay. So think back to the lesson where we looked at what creates the weather. Okay. We have warm air rises, cold air sinks. Okay. Then we added in the Coriolis effect of the planet itself spinning, right? And then we added in land breeze, sea breeze, because, water and land heat and cool at different rates. Okay. So for planets that have land masses and ocean masses, those kinds of things, it's potential because it's the same physical processes that are taking place. Now, Jupiter is a big ball of gas.
right.
Okay. And so uh, it's not going to have solid land mass or liquid water. Okay. But you still have the Coriolis effect. You still have that, warm things rise and cold gases sink. And so if you were to look at some of the videos of, from satellites that have explored Jupiter and Saturn and the other, you can see things like cyclones or hurricanes taking place because it's the same physical processes. Okay. Does it manifest itself like we do on this planet Earth, where we have, 70% of the surface is water, and we've got, the majority of land mass in the north and the majority of the water mass, down in the southern hemisphere? Will it play out the same way? No, but the same physical processes do. I mean, God doesn't make physics work one way on our planet and make it work differently on another planet, but the actual properties, how much water, liquid water, temperatures, all those things still come into play. But the physical, the laws of physics didn't change. They just interact differently with different results because of what's available to the physics to
Oh,
work
so
with.
the mechanics are constant, universe-wise. What changes are the ingredients and how it plays out.
Yeah, and you got different ingredients, and so the recipe plays out a little differently.